We're saying f of x is it's a what? What kind of a function is this one? It's a hyperbolic function. Okay. G of x is what? So what do we know about a hyperbolic and an exponential? What are the properties of a hyperbolic function? Okay. They have asymptotes again. Yeah, both of them, they do have what? Asymptote. How many asymptotes does this one have? How many asymptotes does an exponential have? So the other one has 2, the other one has what? Has 1. Okay, so when we speak about 6.1, they say write down the equation of the asymptote of f. F is the hyperbolic function. So what are going to be the equations? Remember, equations, it's x is equal to, is y is equal to, those are equations. So what is going to be x? X is equal to, x should be 2. And then what should be y? Y should be equal to 1. How did you get that? We said whatever the value of q is, that is going to be our y. And then this one we said x minus 2 should be 0. Take this one to this other side, it says which x is going to be what? To be 2. Let's go to write down the equation of the asymptote of g. What are going to be the equations of the asymptote of g? Y is going to be whatever the value of q is. Okay? What is the value of q? It's minus 1. So we get 1 mark here, and then here we got 1, we got 2. Now, on the same set of axes, sketch the graph of f and g in your answer book. Indicate all the intercept with the x-axis as well as the asymptote. So what are we supposed to do here? We are supposed to determine the x and the y-intercept. We need them. So let's start with f of x. What are going to be the x-intercept? So they're not going to mark you this one. You are just doing them because you need them. So you're going to have y, which is going to be equal to 2 all over 0 minus 2 plus 1. When x is 0, what is our y? When x is 0, what is our y? You got 0. Okay, we have 0, which goes with 0. Let's check this one here. What are going to be the x-intercept here? So we have y, which is going to be equal to 1 all over 2 to the power of 0 minus 1. It gives us what? 0. We know the x-intercept. Okay? I'm going to be using 2 different colors. Now we do the same. Let's start with f, so that we don't confuse them. Let's start with f. F. Here's the graph page. What are the equations of the asymptote of f? Let's start with f. X is 2. No? X is 2. We're going to come and say x is 2 here, and then we put a dotted line. This is for f of x, by the way. Doesn't have anything to do with g. What is the other asymptote that we have? Y is what? Y is 1. Okay, we have a point of intersection here. X is 2, our y is 1, like this. Okay, now we need to get the x-intercept. What is the x-intercept? It's 0 is to 0. Now let's go to our calculator and then type this thing so that we can get the shape. On your calculator, you're going to type f of x. What are you going to have for f of x? You have table, mode, and then you go to table, and then you say which you have fraction, you have 2 all over alpha x minus 2 plus 1, like this. And then where do we start? We just want to include everything again. So we can start at minus 2 here, or we can start at minus 1. So we start at minus 2. Where are we going to end? We can just end values after the asymptote again. The vertical one. We look at the vertical one, so we can end at 4. Or we can end at 5. It doesn't matter. Step, we leave it as 1. I did something, I don't know. I pressed something. Step, it's fine. Okay, sharp. So minus 2 goes with 0.5. Okay. Minus 2 is going to go with half. Here it is. And then minus 1 goes with 0.33. 0.33 expected to be somewhere here. And then 1 goes with what? 1 goes with -1. And then these are the values before the asymptote, so we can connect. -1, it's here. Okay, these are the values before the asymptote. How many do we have before the asymptote? We have 1, 2, 3, 4, including the x-intercept. Okay, let's go and connect these dots. If we connect them, we're going to have dot number 1, which goes to dot number 2, which goes to dot number 3, which goes to dot number 4. It's the way I'm seated. I'm not seated right. And then approach this side again. And then also approach this side. Okay, let's get the other one. Error. And then we have values after the error. It's 3. It's 3:3. 3 goes with 3. Here it is. And then we have 4. 4 goes with what? 4 goes with 2. Yeah, and then you only have these 2 dots. You can connect them. And then approaches from this side, and then approaches from this side. And then we'll call this one f of x. Done with f of x, let's go into g of x. Let's start with the asymptote of g of x. What is the asymptote of g of x? It's -1. So you come to -1, and then using the asymptote of g, I'm going to be using a different color. So I'm going to be using this purple color to say now I'm talking about g. This asymptote can touch the green color, but it can't touch purple. So I'm going to be concentrating on purple. So this is why it's equal to -1. And then our x-intercept, we got it as 0 and 0. Okay, now we're going to look for 2 values before and then 2 values after. After this x-intercept. So let's go and write this thing here. We go to our table, and then we type in that one. What does it say? Half. No? So it's 1 all over 2 to the power of alpha. So we should say alpha x. No? And then we say -1. Okay, where do we start? We can start at -2. Where do we end? We can end at 2. Or we can end at 4. It doesn't matter. We'll check which ones are useful. So when x is -2, our y is 3. Hey, pull. X is -2, our y is 3. Here it is. When x is -1, what is y? It's 1. X is 0, it's 0. X is 1, it's 0,5. And x is 2, 0, it's getting closer to the asymptote. And then from the onwards, you can connect your dots. Dot number 1, dot number 2, dot number 3, dot number 4, dot number 5, and then they approach the asymptote. And then this is how our 2 graphs are going to look like, and then they intersect here. And then we're going to get our 4 marks here. Okay, now that we're done drawing, the next question says, determine the domain of f. Now, how do we get the domain of this one? We said x is going to be an element of all real numbers, okay? But x cannot be whatever the vertical line is. What is the vertical line here? F. What is the vertical line? It's 2. X cannot be 2. X is going to be an element of all real numbers, but x cannot be 2. Now, the other way to think about it is this way here. You can use what we call a vertical line. If you're going to be using a vertical line, let's just take a vertical line here. As soon as you have a vertical line here, okay, sharp. You will take this vertical line and then you will shift, and then you're going to concentrate on green. Only on green. And then only on green, we're going to say on green. Forgetting about red first, because we're looking at the vertical. Horizontal one, it doesn't affect us. So what is the first thing that we touch? Negative infinity again. And then we go up until we touch this thing here, which is going to be this vertical line. And then we move on from there. We touch arrow again. And then if we were to move on with this vertical line, The last thing that we're going to touch is positive infinity. So you can say x is an element from negative infinity up until positive infinity, but it can be this. Here's what we're interested in. X cannot be this because it doesn't touch this line. Okay? So x is everything except this line here. So I'm going to say x is an element of all real numbers, but x cannot be 2. Now, that is the domain of f. They say the range of G. Now, concentrate on G. Now, let's look at, go and look at the graph of G. Where is the graph of G? The graph of G is the one which is purple. Okay? And then if we use a horizontal line, let's check here. Do you see any part of this graph here? Because that's what we should ask ourselves. If I start from somewhere here, is there any of the purple color here? Okay, let me shift here. Is there any of the purple color here? 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 So what is the first thing that I touch? The first thing that I touch here, I touch what? I touch the asymptote. Okay? And then after that, I start to touch the purple color up until I touch infinity. So what is going to be this? Unlike the green one, you saw the green one was appearing before the asymptote and after the asymptote. Hence, I said x is an element of all real numbers. This one, y cannot be an element of all real numbers because there is no graph before the asymptote. There's only a graph after the asymptote. Do you hear what I'm talking about here? There is no graph here. There's no any of the purple color. We don't have it. But we do have the purple color after the asymptote. So how then do we write this? Then we're going to tell them y is going to be greater than the asymptote, which is going to be -1. Not greater or equals to the asymptote. It's just greater than the asymptote. The graph appears after the asymptote. That's what you mean by this. You say the graph is appearing after the asymptote. With this one, what did you say? You said the graph appears before the asymptote and it also appears after the asymptote, but it can't be the asymptote. Okay, we are done with the domain and the range. Write down, determine the equation of H, the axis of symmetry of H, which has the negative gradient. This one is simple. If they gave us the equation, this is what we're going to do. I'm simply going to take this part here. And then how are we going to write this thing? Then we're going to write it as y is going to be equaling to. Then we put minus outside. It's minus x minus 2 plus 1. And then this says which y is going to be equaling to. This one multiplied by this one, you get minus x. Okay? And then negative it gives us. And then the answer that we're going to get is minus x plus 3, which is going to be 2 marks here. Now they say, describe how the graph of P of x was transformed to obtain f of x. Let's check. Let's start with f of x. What do we have as f of x? Look at f of x. What is it that you have? You have f of x, which is given as, it's 2 all over x minus 2, like this, plus 1. Now remember, look at this thing. Let's look at this. Let's compare this graph and this graph. This graph doesn't have a 1 again. If you wanted to remove this one, what would you do here? Will you add, if you say plus 1, let's check. If you add plus 1, it's going to say plus 2 again. So you can't add 1. What are you going to do to 1? Yeah. And then if you are going to subtract 1, then you'll tell them which the graph was shifted 1 unit down. Why? Q is exactly the same. It's not the opposite. If it's minus, we go down. If it's upward, we go up. The only one which has a problem, it's x. X, it takes the opposite. If you're going towards the negative side, you add. If you're going towards the positive side, you do what? You subtract. Again, this one here, it's just like if you have something like this, x plus 1 or squared. This one here, your turning point is going to be x is equal to minus 1. It's not x is 1. Just like here, when you're getting the equation of the asymptote, you didn't say the equation of the asymptote is x is equal to minus 2, but you said x is equal to 2. You take the opposite. Okay, then we are going to tell them with the first thing that they did, they shifted this graph 1 unit down. 1 unit down. Okay, now if we subtract minus 1 here, we're going to get this part out. We want to remove this minus 2. How would I remove minus 2? I'm going to add plus 2. Now we should be careful here. I'm adding again. If I'm adding, I'm going towards the negative side. I'm not going towards the positive side. So I'm going to tell them it was shifted 1 unit down and it was shifted 2 units to the left. Not to the right, to the left, because I'm adding. Remember, x takes the opposite. Okay? So you're going to get 1 mark for this, and then you're going to get 1 mark for this. Okay. Calculate the distance between F and G, the intersection of the asymptote. Oh, calculate the distance between the intersection of F with G. So the intersection of F and G, we have it here. And the asymptote. Here are the asymptotes. So they want the distance from here to here, basically. Point of intersection. What is point of intersection? You have 0 is to 0. And then what are the coordinates of the point of asymptote? 2 is to 1. Let me check if I'm interpreting the question correctly. Calculate the distance between the intersection of F with G and the intersection of, or the asymptote of F, yeah, asymptote of F. Okay, so how would you get a distance? We know how to use the distance formula. Distance formula, what does it say? It says distance is going to be given by x2 minus x1 whole squared plus y2 minus y1 whole squared equals to root x2. We can take this point here and make it to be x2. So we're going to have 2 minus 0 all squared plus 1 minus 0 all squared. And then if you type this in your calculator, you get root 5 again. Root 5. And then they will give you 1, 2. 6.9. The graph of G and F intersect at point K, which is 0 and 0. Yes, point K. Point K is 0 and 0. And then after that, they speak about K prime. They call it K prime. And then they say it's the intersection of F of x minus 3 and G of x minus 3. So what is going to be this point K? This one is going to be simple here. They are shifting this graph. They are shifting it vertical. If they're going to be shifting it vertical, you're going to have 3. Again, this one, I'm going to say x minus 3 should be 0. Remember, x, we don't take it exactly the way it is. We take it the opposite of it. Okay? Take this one to this other side. It says x is going to be 3. And then y, because they didn't have any shift, how do I know if there was a shift? They're going to say plus something here. They didn't say anything there. So it means the y is going to remain the same. So this is going to be our k prime. And then you get 2 marks. For which values of x is f of x multiplied by g of x going to be above the x-axis? F of x multiplied by g of x above the x-axis. So we want both of them to be positive. When is f of x multiplied by g of x going to be positive? Let's go and highlight where both graphs are positive. We're going to use a yellow color for positive. So this graph here is appearing above the x-axis again. Appear above the x-axis, appear above the x-axis up until it gets here. This one is above the x-axis, above the x-axis up until it gets here. This one is above the x-axis, above the x-axis, above the x-axis. Now after that, I'm going to use a different highlighter to highlight below the x-axis. Let's use this one. Below the x-axis is this one. And then we don't have any of this graph below the x-axis. So what are we looking for? We are looking for both of them to be above the x-axis. Is there a part where you see both graphs above the x-axis? Where do you see these both graphs above the x-axis? Is this part again? Both of them above the x-axis. What are the x values that are making this to be possible? X should be less than 0. So I'm going to say which x should be less than, is less than 0, not less or equals to 0. Yeah? We want both of them to be positive or equals to 0. We want both of them to be, or it's greater or equals to 0. It's less or equals to 0. And then